All right, continuing along here with automating the data cleaning portion of the data mining framework process. What I want to do now is automatically bin low count group values. So this is really common across a lot of data sets when there are categorical features like neighborhood, for example. Neighborhood is going to matter a lot when predicting how much, what sort of average review that you get in Airbnb listings. However, when there's a lot of neighborhoods, it's likely that some of them aren't well represented, and as a result, they're not very reliable when it comes time to do some modeling and prediction, when we predict the average view count or whatever, review or whatever that might be. And so those neighborhoods that don't have a lot of representation in the data set, we need to bin those all together into like an other category or something like that, so that we don't come up with, for example, regression coefficients for neighborhoods that don't have adequate representation. Let me give you another example. I think I really like using the, well, no, that neighborhood's a good one. Let's use that example. So I'm going to bring down, let's see, each of my data sets here again, and work with these. And let's go ahead and create a new function here to handle this. So I'm going to call this bin categories, and I want to pass in a data frame features to bin. And I'm going to add a couple more parameters. Cutoff equals 0.05. So this is what the minimum percent of rows that need to be represented for each group value in order for us to keep it and not bin it into an other category. So a common rule is 5%. So for example, if I have a neighborhood in my listings here, let's say whatever this neighborhood is, I don't even know how to pronounce that. Let's say that there's only one row for this. That probably doesn't make up 5% of the database, or of the data. I think there's something like 192,000 rows in this whole data set. And so since this makes up less than 5% of the rows, we would want to bin that into other. That's what our cutoff right here parameter is for. But we make it a parameter so that we can modify that. I can think of some reasons to argue that 5% is too high. If I have a ton of data, then maybe 2% is adequate, because I'll still have enough rows. Or if I have a very small data set, maybe it needs to be more like 10%. So making that a parameter is a good idea. Let's give the user the option of what to replace or what to bin with. For example, by default, I'll call all of these neighborhoods other. But by making this a parameter, we'll let them overwrite that. And finally, as I've done before in other function, I like to have that messages option, so that as I'm going through and cleaning data, I get some information. As I'm going through the data set for the first time is what I mean. I get some information back on exactly what my functions are doing. And then later on, when I put these functions into a pipeline, I can set messages to false when I no longer need that information. All right, so here's how I want to work this function. I'm going to import pandas as PD. And I want to iterate, of course, for in features. We'll iterate through all the features that are passed in. And I want to check and first of all make sure that I'm not dealing with a numeric feature, because we don't bin categories if it's a numeric value. If it's something continuous or even discrete and there's a lot of values, that's not the type of feature we're talking about. We're only talking about these categorical features that we're wanting to bin here. So let's just do a quick check. Let's say if not pd.api.types.is numeric dtype, and let's pass in that feature. So we're only going to do this if it's not numeric. Also, as we did before, let's also check and make sure that it's actually in the data frame they provided. So maybe I'll do that as a separate if so that I can give it a specific error message in case. So if feet in df.columns, and if not, then if messages print, just like we did before, feet not found in the data frame provided. No binning performed. Okay, so now what exactly are we going to do when we find a valid categorical column that needs to be binned? So I do this in two steps. First, I'm going to make an other list. So this is going to be a list of values or of groups within this feature. So in other words, a list of the neighborhood values, if that's what we're applying this to, that don't represent at least 5% of the data frame. So to do that, I'm going to say this other list is going to equal df feet.value counts. So I've used value counts a lot, and just to give you a reminder here, let me just print it out down here. df Airbnb dot neighborhood. Let's see if that'll pop up. No, come on. It's not coming up here. Neighborhood group. Oh, it's lowercase n. That's why. Oh, come on. There we go. Neighborhood group value counts. So I just wanted to give you an idea of what this is doing. Oh, come on. Maybe it wants me to put it like this. Oh, get rid of my P right here. Let me pull in that data set again. I wonder if I messed it up somehow. Airbnb. Nope. Oh, I'm looking at the wrong one. Neighborhood group is all nulls. I want neighborhood. Sorry. Some of you probably noticed that and were wondering what I was doing. Okay. All right, here's what I was trying to show you. So it gives me a list of each neighborhood and the number of times it shows up in the data set. So when I make this other list, I'm starting by saying, get me a value counts, and then I want to divide that by the length of the data frame. I can do this two ways. So this gives me the total number of rows, or I can also get the total number of rows by going to shape 0. Same thing, either way is fine. And then I want to, let's see here, I'm going to, right here after value counts, I didn't mean to divide by shape quite yet. What that does is that would give me everything as a percentage. Sorry, I'm kind of thinking out loud here a little bit. So divided by rows, oh, df Airbnb, sorry. So by dividing by the shape, it gives me the percentage that the rows make up of the overall data frame. And what I want actually is to index this right here. I'm going to save this. So I want to go into the value counts. Let me take this off again so you can see it. And I want to get a list of neighborhoods where the value count divided by that shape is less than the cutoff. So to do that, I'm going to index this value counts object right here, and then use a filter, df feet dot value counts. So I'm going to recreate that table again, then add that divide by shape. So this is going to grab all of the rows from this data frame where that count divided by shape right here is less than the cutoff that got passed in right here. So this is going to grab all of the results of this object, grab all of the rows in this series right here where their value count divided by shape is less than 0.05. And from that list, I only want the neighborhood names. So by saying .index at the end, it's going to give me just these names right here on this side. So this is kind of complicated, and I think it would help if I printed this out to explain exactly what this is doing. So let me print the list, and then let's call it right here. So bin categories, pass in df Airbnb. Oh, and it didn't even make it in here. I got to add columns or features. So let's just do neighborhood. Oh, and I got to use the English spelling that they use there with a U. All right, did I still spell it wrong? Copy. Okay, no, this one did work. So let's check my error here. It's on line 7, other list. Let's see. Feature.value counts has no, oh, I need an S right there. Value counts. All right, so this returned a list of neighborhoods that were in that value count list that were less than 5%. So that's what we've got, is just a list. I like to leave, by the way, my errors in here. I do that intentionally. I could edit them out, but I leave them in because I want you to see my process for debugging, reading the errors and how I interpret it and understand how to solve them. Anyway, and I'm a little bit lazy. So we've got our other list, and now that I've got a list of neighborhoods that need to be converted to other, I only need one more line here to convert all of those. I want the values where anywhere neighborhood is set to one of these, I want to change it to other. So I can do all of that in one line using df.loc and say df feet dot is in, and we'll add our other list right here. So I'm going to say for every value of that feature that is in the other list that we generated right above here, for the column called feet, change that to the replace with value that got passed in. In other words, change to other. So once again, go to every row in the data frame they passed in, find every row where the feature that we're currently iterating through is in the other list we generated in the step before, and in that column, replace it with the value that got passed in right here. So it'll change all of those to other. Let's go ahead and run this. Oh, I got to spell is in properly. I-S-I-N. Oh, you know what I forgot to do? Last step. I need to return the data frame. Now that it's been modified, I need to actually return it back here at the bottom. Go down one more line. Return df. There we go. So I'll just say .head right here. Oh, run this first and then run that. All right, perfect. So the very first one, as I thought, that was kind of a weird neighborhood name. Notice it got changed to other right here. The rest of these neighborhood names must have been common enough that they represented more than 5% of the database, and they still got included. I can change, again, remember my parameters right here. I could change the cutoff to something like 50%, which would be ridiculous. Anything that doesn't make up 50% of the database would be changed to other. In that case, everything will become other. So I can always modify this. I could make it a little bit lower. It's got to represent at least 2% of the database. It's another way I could do that. Oh, they were already all converted to other. I need to pull it in again. There we go. So this one does represent at least 2% of the database. But I'm going to leave it at 5. I think that's a pretty good one. So if I just delete that, it'll go back to the default that I gave it right here of 5. Let me pull it in one more time. There we go. Lastly, let's, rather than just printing out the head, I'm going to go to neighborhood dot value counts so you can see exactly what happened. So it looks like it kept a total of, what is that, 8? Kept 8 neighborhoods and binned the rest of them into other. So if I looked at this, I might think, 8's okay. That's not bad. It made other the biggest category of all, which is also not a problem. But I could also see making an argument that maybe 5% is too much. And since we have so many rows in this data frame, I'm going to lower it down to 4%. Well, that still gave us 4. Sorry, rather than change it there, I should be doing it here. Cutoff equals, let's go down to 3 and see what that does for us. Did that give us more? Yeah, it did. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it kept one more. And we could even go down to something like 0.03, 0.025, use more precision or something like that. Okay, other is now the second highest. I don't usually like to see other as my highest category. It's not a problem, but anyway, when I have so much data like this one, I don't think it's a problem to take that cutoff down to something like 2.5%. Because see here, I've got this neighborhood. I'm keeping this one, and it still has 550 rows. That's enough to get a pretty reliable estimate for this neighborhood. So that's it. We've got a function now that automatically bins categories for us. If I wanted to make this permanent, I would just say df Airbnb equals bin categories, pass in df Airbnb, pass in anything else I want. And let's see, I only did this with neighborhood. We didn't practice trying something that doesn't exist. Let's add neighborhood and doesn't exist. If we want to bin anything else, I would look at this and say, okay, name. I mean, name would probably already be gotten rid of by our prior basic data wrangling function. In fact, maybe we should go ahead and call that one first. That's okay. I'll keep this simple and just run this one, df Airbnb.head. So now I'm calling this function and I'm storing the returned results back over the top of this data frame. So I can, this is how I would use it in a pipeline. Run it once more. Oh, I'm glad we ran this because I got an error here. So let's take a look right here, called that. So we checked its data type before we checked to make sure it was in the columns. We just need to reverse those. So it runs this check first. All right, so up here, I'm simply going to move this one inside of that one, which means I'll have to tab these in and then grab all of them to go back. Shift tab. There we go. So now as it goes through each feature, it was getting an error on this line because it was saying we can't check to see if it's a numeric data type because it doesn't even exist in the data frame. And that's where the error out returns. So by reversing those, it will check first and not get that problem, not have that problem again. There we go. Perfect. Let's call it good for this video. We now have something that will automatically bin categories for us so that we don't have to do it manually.